Hi everyone, my name is Ivan. I also have Thường, Kusa, and Anasa as my teammate. Today we will talk about our triple feed-pool system. As you may know, unbalanced pH level of the water in the pool will cause a lot of issues. If the pH level too low, it can cause eyes and skin irritation, or if it's too high, it will cause cloudy water and inactivate chlorine. That's why most owners have to check the pH level every week. And this is the reason we designed this system. Basically, the system will help the users maintain the pH level of the water in the pool automatic. The system will measure the pH level and update the data to the GUI. Based on that data, the system will add on the acid to balance the pH level in the water. Also, the system has some add-on features such as acid tank level, temp sensor, fan, alarm LED, and manual mode. As you can see in proposed design, everything in the system controlled by microcontroller. The microcontroller takes data from sensors and then send it to the GUI. The GUI will send the signal back to the microcontroller to control the pump, fan, and LED. We also design a box to rotate all the components. We have some requirements for our system, such as the GUI have to show signal when it connect or disconnect from the PC. Also, the GUI have to show pH level of the water, the level of the acid in the small tank, and temp inside the box. The pump have to turn on if pH level more than 7.5 and turn off when it below 7.5. If the pH level go over 8 or below 7, an alarm LED will turn on. We also use ultrasonic sound to measure acid level in the small tank. If the acid level less than 30%, another alarm LED will turn on. If the temp inside the box over 80 degrees Fahrenheit, the fan will automatically turn on. Also, the pump and the fan can control manual, and the 3D box have two water loops to rotate all the components inside. Now, Gusa will talk about how the system set up, and Thường will explain detail how the system works.
This is the project setup. That's our application on the computer. It's going to connect via USB cable to the board. This is our microcontroller. This is our temperature sensor. That's a fan to cool the system. This is our acid level sensor, which is basically an ultrasonic sensor. This is the main power switch, and this is the battery. This is our board, the pH sensor board. This is our electrode, the pH electrode. That's our motor. The motor is right here. And this is our bucket that we use to simulate the pool. In this step, we're doing manual testing. We're going to connect the board via USB cable. So you can see everything came to life. Device is found. We're going to test the motor, but before we test the motor, we have to turn on the switch. It's in manual mode. The motor is on. The second step, we're going to test the fan. So we have to set it in manual mode. If we press the on, it should go to 100% in speed. You can also lower the speed. Second, we're going to test the pH sensor. We use a pH value of 10 and we calibrate the sensor to read 10 pH 10. As you can see on the screen, it's showing pH 10 because we already calibrated.
So this is the current temperature in Celsius right now, and we're gonna test with a temperature sensor. I'm gonna put my finger on here, and then the temperature in here, it should increase. So it increased slowly, and we actually also can see it in Fahrenheit. So it's at 84.7 degree F. So right now our pH electrode is in pH 10 solution right now. So we expect our GUI to show the alarm LED to be on, because we set the alarm to be on whenever the pH is above 7.5. So this is our GUI right now, and the pH LED light is on because the pH level is above 7.5. Also, we also set an alarm LED for the acid tank. So whenever the tank level is below 30%, the LED is gonna turn on to tell the user that the acid is very low and he needs to put more acid in there. So right now in our acid tank, the tank is empty, so that's why you see the white light is on. But if I put my finger here to block the sensor, um, you can see that the light change to gray, meaning that the tank is full, so it's off. Okay, so we have put in the pH 7 acid solution in here in order to balance the pH level in our big bucket. In here, we can only put a small amount for our testing purposes due to the limited amount of acid that we have in our hand right now. So the acid alarm is on right now because it's below 30%. So the acid level is showing 2 centimeter. The maximum that it can go is around 9.5 centimeter. That's the maximum height of the tank. So here, when we uncheck the manual mode, the pump is gonna go into automatic mode. Now the pump is on because the pH is 8.1. In here, we use the pH up solution in order to increase the pH level in our bucket to 8.1. Now we're gonna mix the water a little bit so that the pH and the acid mix evenly in the solution. And once it reaches 7.5, it's gonna stop working. And right now you can see it's around 7. So as you can see, the pump stop running when the pH level is below 7.5. So now when the pump stop, the reason why the pH level is at 7.1 is because that we in here we tested with a bucket, but in real life for a real pool, they're gonna have a filtering system that is gonna continuously filter the water. And also the pool tank is around 10,000 gallons, so the sensor is gonna read more accurately, and then it's gonna stop it at a more precise time. But in here, our 7.1 value is still in the safe range between 7 to 8. So the pH LED alarm is off for now. So it's working according to our requirement for this project. So in addition, the reason why we only able to use a little amount of water in this bucket for our test is because we only have a limited amount of acid solution in this small tank. And for this limited amount, we can only use it much water so that they can balance out and reduce the pH to 7.
Now Kusa will explain how we design GUI and program the system. Also, Anasa will show the layout of 3D design.
In this part of the video, I'm going to talk about the layout of the graphical user interface. Once you launch the program, on the far left you will see the pump control. By default it's in manual mode. In automatic mode it will run off the pH sensor value. Here we have the sensor readings. Here will display the temperature. Here it will display the pH level. Here we could choose the temperature scale, which is in Celsius or in Fahrenheit. Here it will display the acid level. Here will display the voltage on the 5 volt power supply rail. Here are the alarms. We have the acid low level alarm. Once the acid level drops below 30%, this alarm will turn on saying the acid level is low. Then we have the pH alarm. Once the pH is over 8, it will say water too basic. If the pH is below 7, it will say water too acidic. On the far right, we have the fan control. In auto mode, it will run off the temperature reading. In manual mode, we can control it with the off and on button, and we can control the speed using the slider. Here at the bottom are the data acquired from the microcontroller, which can be used for troubleshooting. Here, a program is telling you the device is not plugged in. It's saying device not found. So we're going to plug in the device. As you can see, the software came to life. For the fan, we can set it in manual mode, and then we have control of the slider. Here we are seeing the data from the chip. Here it's saying the device is found. Currently the acid level is 0 because the tank is empty. In this part of the video, I'm going to talk about the PCB board design, the program, and the software that we use in the design process. First, I'm going to talk about the program. The GUI was designed in Visual Studio. Here you can see the form. Here we can drag and drop pictures, buttons, radio buttons. This is where we do the coding. For the program, for the microcontroller, we use Micro C Pro. Here we can write the program in C for the microcontroller. For the board design, we use NI Altiboard. This is the final design. Here you can see the 3D view of the board. These are the traces. This is where you run the traces for the board. So our first design looked like this. It was very simple. However, this didn't have any connection for the pH sensor, and we also want it to be expandable. So that's the reason why we designed this board. The schematic was designed in EagleCAD. This is the final schematic for our project. So for the board, once we designed the board, all we had to do was to export the file, the Gerber files, and send it to be fabricated. This is a picture of the fabricated board. That's the top view. This is the bottom view of the board. And this is just a picture to compare the circuitry on the breadboard and the one on the PCB. When we finish, write the program for the microcontroller, and we build the project. It will generate a hex file, and we use the PIC3 to load the program on the chip.
This is our 3D design box for our project. The total dimension of the box is 11.5 inches for the length and 6 inches for the width and 2.74 inches for the height. The box is separated to three sections by two walls inside the box, and the first section is the battery section. The battery section has 2.84-inch length, and the PCB section has 3.54-inch length, and fan and pump section has 3.14-inch length. And there are four supporting legs around the box, and the height of the legs is half inch, and the purpose of the leg are to ensure that the water will not go through the box and ensure the fan will suck the air from the outside. There are four holes in this side of the box. The first two holes are for the pump tube, and the third hole is for the pH sensor and is bigger than the other holes because the pH sensor radius is bigger than the wires. And the fourth hole is for the ultrasonic sensor. Also, there are another rectangular holes in the other side of the box in the PCB section to connect the USB cable from the laptop to the PCB. Also, there are rectangular holes in the walls inside between the battery and the PCB, and another rectangular holes in the wall between the fan and the PCB for the wiring purposes. Also, there are small holes for the fan for the cooling purposes. The cover of the box is designed to be waterproof and ensure that water will not go through the box. And the height of the cover is bigger than the regular box to make sure there are enough space for the air to flow inside the box for the cooling system. If we put down the cover in the box, you can see the holes are matching and the box gonna be sealed and no water will be inside the box. And here is the design where the fan and pump section and the PCB and the battery section, and this is how the box gonna look like.
As you can see, our system meet all the requirements, like the GUI show the data very accurate, or the pump and the fan can turn on and off automatic. Also, the pH level of the water can stay in the accept range. So we think our system will be an awesome tool for pool owners.